Okay, hello, welcome to my channel. Now in this video, we want to find the derivative of this function y equals to the square root of cosine square x divided by cosine square x plus sine square x, given that x lies between 0 and 90 degrees. That is, x lies between 0 and pi over 2. Good. Okay, this function looks more complicated, but it is very simple, all right? I'm just going to use the fact that since I restrict my angle x to be an acute angle that is between 0 and pi over 2, and it can even be 90 degrees, but it just lie in there, right? Maybe let me remove this, just between 0 and 90 degrees, right? I can visualize this using a right angle triangle, and real quick, the hypotenuse side is going to be 1. Now when the hypotenuse side is 1, given that the angle here is just x, okay, sine x will be opposite of hypotenuse, so opposite is sine x, all right? And then adjacent will be the cosine x. So I just put it down here. Adjacent is cosine x. By Pythagoras rule, so the whole of this will imply that, okay, the whole of that will imply that by Pythagoras rule, the square of the other side, that is the square of 1, is the sum of the squares of the other two sides, right? That is sine x squared plus cosine. So that means that 1 is sine square x plus cosine squared x, using the fact that sine x is opposite over hypotenuse. That will be opposite over 1, which is opposite. So sine x is opposite. Cosine x is the adjacent. So that means that 1 is sine square x over cosine square x. So the denominator here is going to be 1, all right? So that means this function is the same as the square root of cosine squared x divided by 1, which is just cosine x, right? That is, y there is the square root of this, just the positive square root, which is cosine of x. So the whole of that function can be rewritten as just cosine x. And the derivative of this cosine of x, so I just put it down here, the derivative with respect to x of y will now become the derivative with respect to x of cosine x. And that right there is just minus sine x. And this right here is the derivative of that function. Okay, great. All right, thanks for watching. Please subscribe to my channel.